A 50 Newton force acts on the rod at point A as shown in figure. Determine its moment about point O. So here we can find out the moment of force about a point by three different methods. You can use any method of your choice as per the convenience. So the first, we are going to find out moment of force by calculating perpendicular distance. Perpendicular distance from the line of action of the force to the point. Right? So with the line of action of the force, just extend the line along 50 Newton force. So draw perpendicular from point O to the line of action. Say this perpendicular distance is D. So from figure you have this angle as 30 degrees. Let us say this O A B. From the right angle triangle O A B sin 30 is equal to opposite side is D upon hypotenuse 2. So D is equal to 2 sin 30, that is 1 meter. That is the perpendicular distance. Therefore, moment of the force about point O. Now tell me what is the sense of rotation of the force about point O? It is clockwise. Right? The force is tending to rotate in clockwise direction about point O. So minus 50 into perpendicular distance is 1. So minus 50 Newton meter. So it is 50 Newton meter clockwise. It is the moment of 50 Newton force which is acting at point A about point O. Then sometimes it is very difficult for us to determine this perpendicular distance from the line of action. In such cases, you can resolve this force into perpendicular components. And by using Verigna's theorem, you can find out the moment of force. So by resolving the force into perpendicular components, second method, resolving force into perpendicular components along and perpendicular to the rod. I am not resolving along horizontal and vertical or along x or y. So I am resolving the force into two perpendicular components. One is along the rod, the other perpendicular component is perpendicular to the rod. Right? Now this component along the rod is making 30 degrees with respect to the force. So you can write this component as, yes, how much? The component adjacent to the angle is cos 50 cos 30. Other component is 50 sin 30. Now as per Verigna's theorem, what is Verigna's theorem? So algebraic sum of the moments of the forces about any point is equal to moment of resultant about the same point. Now here 50 is the resultant of these two components. So algebraic these two components about point O is equal to moment of 50 Newton about point O. So the moment about point O. Now tell me, what is the moment of 50 cos 30 about point O?
0.
Because
0.
the line of action of this component is passing through point O. So it is 0. Now what is moment of 50 sin 30 about point O? What is the sense of rotation? Clockwise. Minus 50 sin 30 into perpendicular distance from the line of action of the force. That is nothing but 2 meters. So 50 sin 30 is perpendicular to the rod. So into 2. That gives you again minus 50 Newton meter. 50 Newton meter clockwise. Now we are going to resolving force into x and y components, horizontal and vertical components. So I am resolving this 50 Newton into horizontal component and vertical component. So to resolve a force into its components, you must know the angle made by the force either with respect to horizontal or vertical. You tell me, what is the angle made by 50 with respect to horizontal? How much
40.
is that? Yes?
40.
40. Right. So it is given the angle made by this rod with horizontal is 70. So here this total angle made by the rod with horizontal is 70. 70 minus 30 gives you 40. Now the component adjacent to the angle is cos. So here x component is 50 cos 40 and y component 50 sin 40. Again taking moments above O and using Verignane's theorem. Taking some of the moments of these two components. You tell me now, what is the moment of 50 cos 40 about point O? 50 cos 40 is acting horizontally towards right. So it is forming clockwise sense. Minus 50 cos 40 into perpendicular distance from the line of action of the force to point O.
2 sin 70.
Right. So if you consider this rectangle OAC, you have this as 70 and this is 2 meters. So OC, adjacent side is 2 cos 70, opposite side is 2 sin 70. So for a horizontal component, this vertical distance is the perpendicular distance, 2 sin 70. 2 sin 70. And what is the moment of vertical component about point O? What is the sense? It is acting vertically upwards. So it will create again which sense?
Anti-clockwise.
So the vertical component which is acting upwards, it will create anti-clockwise sense. So it is plus 50 sin 40 into perpendicular distance from the line of action of the force to point O, that is nothing but OC, 2 cos 70. By solving this, you will find that it is again minus 50. So it is 50 Newton meter clockwise.
Sir,
And if it is 0, Yes.
I'm asking about the angle which consists of the 40 degree. I was not able to see that last one.
40.
Yes, about that.
Okay. So I will redraw this figure. How that 40 has come. You see the rod OA making an angle 70 degrees with horizontal. It is given in the figure. And this force of 50 Newton is making an angle 30 degrees with respect to OA. Now I am finding the direction of 50 Newton with respect to horizontal. See, the direction of OA with horizontal is 70. So the direction of this line is nothing but OA with horizontal. So this total angle is 70 minus 30 gives you the angle made by 50 with respect to horizontal. That is 40. Right? This total 70 minus 30. That is the 40.
Yes, sir.
A 150 Newton force is applied to the rod as shown in figure. So determine 1. The moment of force about point O. 2. Horizontal force applied at A, which creates the same moment about point O. And third, smallest force applied at A, which creates the same moment about point O. So here 150 Newton, this force is acting vertically downwards at point A. So first we have to find out the moment of this force about point O. That you can do it easily. Moment of force is equal to force into perpendicular distance from the line of action of the force. So what will be the perpendicular distance? It is 20 cos 50. Right? Adjacent side. And the sense is clockwise. So it is minus 150 into 20. Yes.
Sir, is the answer minus 10 Newton meter?
Right. Minus 150 into 20 cos 50.
Yes, sir.
It is minus 19.
1928.6.
Right. 1928.36 Newton meter.
Sir, for second 125.91 Newton and for third 96.45 Newton.
Right. So it is 1928.36 Newton meter clockwise. So the second part. So you have to find out the horizontal force applied at A. I am saying it is FH, which creates the same moment about point O. Now tell me what is the moment of this FH about point O? It is creating clockwise moment. So moment about point O, it is minus FH into what is the perpendicular distance from the line of action of that force to point O? That is 20 sine 50, opposite side. So into 20 sine 50. this must be equal to minus 1928.36. We said that which creates the same moment about point O. That is minus 1928.36. That gives you the horizontal force. $125.86. Writing horizontally towards right. Now third part. You have to find out the minimum force at A which creates the same moment about point O. We know that moment of force is equal to force into perpendicular distance. Here, this moment is constant. You have to find out the force, minimum force, such that it will create the same moment. So, for a constant moment, force is minimum when the perpendicular distance is maximum. For a given moment, if the perpendicular distance is maximum, the magnitude of force will be minimum. Now, here you have to find out the direction of that force such that you will get a maximum perpendicular distance from the line of action of that force to this point O. Say, when the force is acting horizontally, 20 sin 50 is the perpendicular distance. When force is acting vertically, 20 cos 50 is the perpendicular distance. These four extreme cases, horizontal and vertical. Now you find out the direction of the force, let us say P, such that this 20 meter is the perpendicular distance. See, in a right angle triangle, you have this is 20 cos 50, this is 20 sin 50. Then perpendicular is always having greater length. So you have to find out the direction of force such that this 20 meter itself is perpendicular distance. Are you getting my point? So from where force is acting at point A, you have to find out moment at O. So you cannot have any other distance which is maximum than 20 meter. So we have to adjust the direction such that this 20 meter is perpendicular. Then automatically this force will be minimum. Understood? Now tell me, what is the direction of this force? What is the direction of minimum force? You have
Clockwise.
this
Clockwise.
No, direction means this is angle. I'm talking about angle.
40 degree.
Yeah, this is 50, 90, so you have this as 40. Again, this total is 90, so you will have this as 50. Therefore, this angle is 40. So, moment is minus 1928.36 is equal to minus P into 20. 20 is the perpendicular distance which is maximum, therefore P is minimum for a given moment. That gives you the minimum force which creates the same moment about point O. 96.42. But what is the direction? Making 40 degrees.
Sir,
With horizontal. Yes.
we are doing it by using Varignan theorem, right?
Varigna's theorem. You can do using Varigna's theorem also. Here you can easily find out the perpendicular distance now. Therefore, I am not resolving into the xy components. Please note down example 3. replace 750 Newton force acting at point C as shown in figure with an equivalent force couple system at point A. So here, a force of 750 Newton is acting at point C on a bracket ABC at an angle 30 degrees. Now you are asked to replace this force with an equivalent force couple system at point A. So as per principle of parallel transfer of forces, when a force is transferred parallelly from one point to another point, that force is accompanied by a moment or couple whose magnitude is the product of force and the perpendicular distance between the lines of action of the forces. Means to replace the given force which is acting at A with force couple system at which is acting at C with force couple system at A, simply you find out the moment of 750 Newton about point A and then show 750 Newton at 30 degrees along with the moment. That is equivalent force couple system. Are you getting my point? Whenever it is asked to replace the force with equivalent force couple system at a particular point, simply you have to find out the moment of that force about that point. And at that point you show that force and moment. That is equivalent force couple system. Now our point of reference is A. So if you find out the moment of force about point A, for that I am resolving this force into horizontal and vertical components. Horizontal component is 750 cos 30, vertical component 750 sin 30. So in order to find out the moment of 750 about point A, I am using Verignon's theorem by adding the moments of these two components about point A. You tell me now, what is the moment of horizontal component about point A? Sense is clockwise minus 750 cos 30 into perpendicular distance from the line of action of the force to point A. That is nothing but 2 meters. The moment of vertical component about point A. What is the sense of rotation? Anti-clockwise. So plus 750 sin 30 into perpendicular distance from the line of action of the force to point A. Nothing but 3 meters. So this gives you moment of 750 Newton about point A.
At 174.
Right. So it is minus 174.04. So 174.04 Newton meter clockwise. So now what is the equivalent
Excuse me,
force
sir.
couple system at point A? So at point A, force of 750 Newton acting at an angle 30 degrees with horizontal along with a clockwise couple of magnitude 174.04 Newton meter. So this is the equivalent force couple system at A. Means what we have done? We have transferred the 750 Newton parallelly to point A. Therefore, I am showing here 30 degrees with horizontal. So it is parallel. When a force is transferred parallelly, that force is accompanied by a moment or couple. That is moment of that force about point A. That is 174.04 clockwise. Now you tell me, same example, find out equivalent force coupled system at point B. Equivalent force coupled system at point B. Means what you have to do? Simply you have to take the moment of force about point B. Right.
There is clockwise. Moment is clockwise and it's 1299.
1299. Correct. So when you are taking moments about B, the moment of this vertical component will be 0. Line of light is passing through it. Moment of horizontal component is clockwise. So minus 750 cos 30 into perpendicular distance is 2. So that is 1299 point. Yes, how much?
038.
90.
03 Newton meter clockwise. So what is the equivalent force coupled system at B? Force is 750 Newton acting at an angle 30 degrees with horizontal, and couple is clockwise of magnitude 1299.03. So this is the equivalent force coupled system at B. Understood?